So lesson 5.4, equilateral and isosceles triangles. So let's look at the parts of an isosceles triangle. If we're talking about just any triangle, you have the sides of the triangle and you have the angles of the triangle. No special names for the angles of the sides. But if you have an isosceles triangle, there are names for the two legs that are congruent, or the two sides that are congruent. We call them the legs. And the third side is the base of the triangle. It's not always going to be sitting on its base, but the side that is not congruent is the base, and the two sides that are congruent to each other are the legs. Then you have your angles. Your one angle, which is across from the base that is not congruent to the other two sides, is your vertex angle. The vertex angle is formed by the two sides that are the same length. Then you have your other angles, and they are formed by the legs and the base, called your base angles. So what this isosceles triangle theorem is saying that is, if the two sides of a triangle are congruent, then the two base angles across from them, or the two angles across from them, are congruent. So if these two sides are congruent, then the side across from those two, the angle across from those two sides are congruent to each other. Because there's a relationship with the side of an angle, of a triangle, and the angle across from it. The converse is also true. If these two base angles are congruent to each other, then the sides across from the angles are congruent. So let's take a look at that. What does that actually mean? How are we going to be using that? So let's take this triangle. And if I just have this triangle and ask you if it's an isosceles triangle, you would probably say yes, because it looks like one. But there is no information on this triangle that tells you that it is for sure. This one side could be off by 1/10 of an inch, or maybe 1/100th of an inch. But there's two different ways to tell if it's an isosceles triangle. One way is this, right? We know that already. If two sides of a triangle are congruent, it's an isosceles triangle. Well, that theorem says that if these two sides are congruent, the angles across from them are also congruent. So in an isosceles triangle, the two sides are congruent, the angles across from the two sides are also congruent. The converse is also true. If these two angles are congruent, then the sides across from the two angles are congruent. So that means that I can determine that this is an isosceles triangle just by knowing that the base angles are congruent. So two ways to tell if it is, three ways. They can tell you it's an isosceles triangle. The two sides of two of the three sides would be congruent to each other, or two angles being congruent to each other will tell us that that is an isosceles triangle. So this is happening in every isosceles triangle. Even in, let's say we do one that looks a little bit different. This is a right triangle, and these two sides are congruent to each other. This is a special right triangle. Something special about it. Which is the base? This one? Okay. So here's your base. It's not sitting on its base. Here are the two legs. Here is the vertex angle. So this is just giving you a preview into something we're going to be looking at in used to be chapter 8. I'm not sure what chapter it's in now, next semester. This is a special right triangle. What are the measures of these two angles? Remember what we said about a right triangle, the other two angles? 45. Good. Because we know these two have to add up to 90, right? Well, if they're congruent and add up to 90, then you half that number, right? Which makes them 45. So this is a 45, 45, 90, which makes it a special right triangle, and we'll study that later. We're going to be studying triangles all year long, even when we're studying circles. Then we have, what does this look like? Equilateral, but we don't know until I do this. Now we know for sure it's an equilateral triangle. Now, I told you already that there's a relationship in triangles with the sides and the angle across from that side that form, because that angle helps form the length of that side. You open the angle up to be larger, that side gets longer. You make it smaller, that side gets shorter, right? You take any two sticks, let's use like sticks of whatever length. Let's say one's longer than the other. The closer they are together, the shorter that third side of that triangle is. The farther they are apart, the bigger that angle is, the longer that third side is. So there's a relationship with the angle and the side across from it. And in the isosceles triangle, we see that these are congruent to the one across, but this is the vertex angle. It is affected by the length of this side, but we don't know if it's congruent to the other angles. But in this one, if you use logic, if these two sides are congruent to each other, the angles across from the two sides are congruent to each other, what logic can you use on the equilateral triangle about the angles? They're all equal. They're all congruent to each other. Okay? So, two ways to identify an equilateral. All three sides are marked, or you can just have this and know that it's an equilateral. Because if all of the angles are the same measure, then all of the sides are the same length. One other thing that's special about the equilateral, let's go back and look at this one. Just because I know this doesn't mean I know anything about the measure of these two angles. I know that all three add up to 180, but unless I know one of those angles, I cannot figure out the other two. There's no way. But in this one, there is a way. If they all add up to 180, what does each angle have to be? 60. Always. That never changes on an equilateral triangle. Okay? This is what I love about geometry. This is a puzzle that we have to figure out. We have this figure, and what they're asking for is not straightforward. So you have to rely on information, on things that you've learned in the past. So I'll give you a minute to look at that figure and think about how in the world are we going to find x and y. So as I'm looking at this figure, I'm like, okay, what's the relationship with x and y? Well, I know they have to add up to 90. We know that, right? In a right triangle, the two angles that are not, the two acute angles, this angle and this angle, add up to 90. They're complementary. Do you know?
I think
You have to use a lot of logic.
Couldn't she set y and 40 equal to 90 since they would be able to
Now this triangle with y and 40 in it is not a right triangle. Mm-mm. But you do, 40 is the only, well, we know this is a 90-degree angle, but 40 is the only other angle we know the measure of.
when you have the x or the angle x, wouldn't that be congruent to the and not the right angle, but like
This one?
Yeah, that.
Yes. So you're telling me that this could also be x
Yeah.
because they're congruent to each other. Good. Yes.
It's like the extended, the two sides of x on them.
Is it up here? TJ?
Alternate interior posture, 40.
We don't have parallel lines.
Oh wait, well, it's a straight line from the 40 degrees. So when the angle up top, not the two x's, wouldn't that be 140?
Which one? This one? This one.
Yeah.
Okay, I wanted that, you're right. And were you trying to say a linear pair? Is that what you were trying to think of?
Thinking about this too.
Let's use words here. First of all, that's a linear pair. Also, tell me, what is the name of this angle? Everybody in here. No. No. We don't have parallel lines. Hold on. Okay. For just a minute, here's what you have to figure out in geometry. Sometimes you look at the big triangle, sometimes you look at the little triangle, and you have to let other stuff kind of fade away into the background. So if I fade this away and only look at this triangle down here, what is the name of this angle? Vertex angle. Because I have an isosceles triangle. So this is the vertex angle, which makes a linear pair with the angle that's 40 degrees. So I can find the measure of the vertex angle, which will allow me to find the measure of the other two angles. So the vertex angle is, I think someone already said, 140. So now I can find x, because I know that this angle plus this angle plus this angle has to add up to 180. So x plus 140 equals 180. So that's 2x plus 140 equals 180. Subtract 140 from both sides. Two x equals 40 divided by 2, and x equals 20 degrees. And let's see, does that work? 20 plus 20 is 40. 40 plus 140 is 180. The interior angles of this triangle equals 180. TJ.
Or do you want, I don't know if you want to go to the next part.
Okay, to find y. Okay.
Well, since it's a right angle,
Right, wait a minute. A right what?
Right.
Triangle.
Well, I mean, I'm talking about the right angle. Right angle.
Okay, since you have a right angle.
Right angle is 90 degrees, and since you already have 20 degrees, the angle opposite of y would be 70.
Okay. Okay, so there's two ways to find y. All three angles in the big triangle add up to 180, or there's a shortcut that y plus x, which is we now know is 20, is equal to 90 degrees. That's what I was looking for you to tell me, but it doesn't matter. It works out either way. So he's saying that 90 plus 20 plus y equals 180. That will give you the same answer as saying that this angle plus this angle equals 90 degrees. So y is equal to, when you subtract 20 from both sides, 70 degrees. Good. Okay, let's look at another one. There's no good way really to show that. It messes that figure up. Let's at least make that smaller. And you can follow in your book, number 16 on page, if you're having a hard time seeing that. I know the sun comes in and messes up the projection there a little bit this time of day. It's on page 256. Also could make that larger, I guess. Group it together. Might help a little bit. We have to find x and we have to find y. Well, it looks like that those expressions are representing the sides of the triangles, and we only know something about the angles of the triangles. Nicholas?
Well, if you don't look at the left part of the triangle, all the angles are congruent, so that's an equilateral triangle.
Equilateral. So can I do this?
Yes.
Yes. Good.
Set 5y minus 4 equals.
Okay, I can do that. Will I be able to find X or Y if I do that?
Oh, yeah, no, you can.
But you're close. Look at it again. There's something else. Now let's look at the other triangle. What do we know? What can you call the other triangle? An isosceles, because the what angles are congruent? Base angles. And that means what? This side is congruent to this side? No, because that's the base. This side is congruent to this side, and I can put one mark there, because if they're congruent to each other and this one's congruent to these two, then all four sides are congruent to each other. Which means, by the transitive property, these two are congruent. So 5y minus 4 is equal to y plus 12. Subtract y from both sides. 4y minus 4 is equal to 12. Add 4. Y equals 16, divide by 4. Y equals 4. Now, if you're not good at solving equations, you're going to be, right? We've been doing this since the beginning of school. We'll be doing this all year long. So if you're ever not good at this, you should be by the end of this year. Should be by now. Okay. We have to now find X. So you don't always have to find them in order. So if we know that Y is 4, what is Y plus 12?
6.
So that means all 4 of these sides are 16 units long. So then, yes, 16, so 3x minus 5 is equal to 16. Divide by 3. X is equal to 7. I don't know about you, but that's fun to me.
It's fine.
Wait, what was it? So much fun.
What now? What's the question?
Why would 3x minus 15 equal 16 again?
3x minus 5?
3x
Because
minus
so if I know the measure of this side,
Mhm.
and I do, it's the same as the measure of this side.
Oh,
And if this
okay.
side is 16, then that means 3x minus 5 has to equal 16. And I could find the measure of all those angles if I wanted to. Let's take a quick look at that. 60, 60, 60. If this is 60, this is 120. If this is 120, let's do some quick calculations in our head. If this angle is 120 degrees, what do we know about these two? They're both 60?
No, they're both 30.
They're both 30. They have to add up to 60. Good. All right. So what is the name of the angle in an isosceles triangle that is different from the other two? Vertex angle. And then the two that are the same measure? Base angle. What is the side that's different from the other two? The base. And what do we call the sides that are the same length? The legs. So you have vertex angle, base angles, base, legs. Equilateral triangle, all of the sides are congruent, all of the angles are. And what are the measures? 60 degrees. Okay. There you go. Yes.
Oh, that's short.
Okay, a hypotenuse is in a right triangle. It's the side that is across from the right angle.
Thank you.
You're welcome.